In this recording, we discuss a classical demonstration. What we have in this case is a gun that we can aim straight at a monkey that would be sitting here. Now, the minute we shoot the gun, the minute we press the trigger, the monkey, fearing for its life, is going to let go of the branch it's holding, and it's going to fall straight down. Now, as it falls, the monkey is going to be subject to a unique force. That's the gravitational force, or the pull of the earth on the monkey. Because of that force, the acceleration of the monkey is going to be downward at 9.8 meters per second squared. On the other hand, the bullet, the minute it comes off the gun, is going to be subject only to one force as well. Okay, note here that for both monkey and bullet, we are ignoring the effects of air resistance. Okay, now, the minute the bullet is off the gun, it is subject only to the gravitational force. So the force on the bullet is going to be Fg, Earth, on bullet, meaning that the bullet is going to accelerate as well at 9.8 meters per second in the downward direction. Now, what does that mean? What does the gun impart on the bullet? It imparts an initial velocity, initially pointing in the straight path toward the initial position of the monkey. Now, that velocity has two components. A component along the horizontal and a component along the vertical. The component along the horizontal is not going to be affected by the gravitational force. However, the component along the vertical is going to be affected by the gravitational force. Now, since the acceleration is the same, the change in the vertical position of the bullet at every second is going to be the same as the change in vertical position of the monkey. What does that mean? Okay, let me erase this. Now, the straight path aimed towards the monkey will make the bullet move in a straight line if we don't have an acceleration. However, because of the acceleration along the vertical, the bullet is going to deviate by this much during that first second. What we are saying, the monkey has moved at that first second by the same amount. Now, what about the second second? The second second, the monkey is going to move this much to that second position, from here to here. Now, what's the bullet going to move vertically? It's going to be the same change in position along the vertical, which means if we deviate from here, we have already moved this much, so it's going to be this much plus this much. So we deviate from the vertical that full amount. That's what we see here. Third second. By the third second, the monkey would have moved all the way to this new position. bullet would have deviated from the straight path by that equal amount. 4 seconds, equal amount, and so on. Okay. Let's look at that in the simulation. Here is the simulation. Okay, actually it allows us, if we remove this check here, to orient the gun any way we want, so we can aim off the monkey, for example, like here. So we didn't shoot the monkey. Now we can actually move the monkey and we can move the gun. Okay, I'm going to reset it and aim it at the monkey. And as we play here, notice that the bullet deviates off the straight line path. And you see the straight line path the whole time. And because of the free fall of the monkey as well, it meets its destiny here. Now, let's run that so you can see it showing the paths. This is the drop. Okay. So we repeat it again. Notice here it's showing us that the change in displacement for the bullet is the same. The change in position of the bullet is the same as the change in position of the monkey. Okay? That's what we are seeing. Now, one might ask, what happens if we get the bullet to move faster? Okay, same thing. What would happen if we get it to move slower? I'm not sure if we are going to be able to see it in the screen, but the monkey is going to still be hit. Okay, we don't see it on the screen. But you see the vertical displacement is the same. So if there is more room for the monkey to move, it's going to be hit again. So it would have been smarter for the monkey to stay in the same location.